Today we'll see lesson polynomials. In this lesson, points to study are polynomials, zero of a polynomial, nature of the graph, geometrical meaning of zeros of the polynomial, relationship between zeros and coefficients, division algorithm for polynomials. All these points we will learn according to the exercise. First, let us see what is polynomials. An algebraic expression in which exponents of the variables are whole numbers, or we can say non-negative integers. It's called a polynomial. That means expression supposed to be the algebraic. And in that one, what you are going to see? In that one, first you will see the variable and then its exponents. Those exponents supposed to be whole numbers. Then only that expression will be the polynomial. Correct? Let us see the first example here. In this one, x square plus 3x plus 2. Look at the variable x. Now look at the power of x. Here, power of x is 2 and here no number is seen. It means that power of x is 1. So 2 and 1 are the whole numbers. Therefore, this expression is a polynomial. Come to the second one here. Here, once again you see the variable. Variable x is present and the power is 1 here. And 1 is the whole number. Therefore, it is also a polynomial. Look at the third one here. Here, power of x is 1 by 2. It's a fraction. It's a fraction. That means it is not a whole number. Therefore, it is not a polynomial. Right? Look at the fourth one. Root x plus 3. Root x means what? X raised to 1 by 2. This root x, we have written the exponential form. Correct? So, once again, the exponent is what? In fraction. It is not the whole number. Therefore, it is not a polynomial. Correct? So, have you understood the difference between the polynomials and non-polynomials? As soon as you see the exponent in fraction, maybe the negative, then you can directly say that it is not a polynomial. Correct? Let us see here one example. I'll tell you. Suppose I write down x raised to minus 2 plus 3. So here exponent is negative. It is not a whole number. That means this is also not a polynomial. Right? Now come to this one, degree of a polynomial. Degree means what? The highest power of the variable in a polynomial is called degree of a polynomial. Correct? Highest power of the variable. Now look here, the first one, 2y minus 5. Your y is a variable, the power is 1. Only one variable is present over there and the power is 1. So definitely degree becomes 1. And whenever degree of the polynomial is 1, that type of polynomial we are calling it as a linear polynomial. Okay, now come to the second one here. Now observe all the terms. 3x minus 4 plus 2x square. Now at 2 plus x is present. Now look at the power. 2 and 1 here. So who is the bigger one? 2. So degree of the polynomial is 2. And whenever degree of the polynomial is 2, that type of polynomial is called as the quadratic polynomial. Look at the third one here. Look at the highest power, which is 3. So it is cubic polynomial. Correct? So cubic polynomial. Look at the last one here. 7. It is just a constant number, but that constant number we can write down in this format. 7 into x raised to 0, because x raised to 0 is 1. In this format we can write down. Now the power of x is what? 0. Now no other x is there who is having power more than 0. So degree of this polynomial is 0 and this polynomial is called as the constant polynomial. Right? Now just see here. Suppose I take minus 2, which is equal to minus 2 into x raised to 0. So degree becomes 0 and this polynomial called as the constant polynomial. You can take any constant number. So that constant number is called as the constant polynomial and degree of that one will be 0. Correct? Let us see the other one. Zero of a polynomial. The real value of the variable for which the value of the polynomial becomes 0 is called the 0 of the polynomial. Try to understand it. What they said? The real value of the variable. So the value of the variable, because of that the polynomial becomes 0. That value of the variable is called as the 0 of a polynomial. Don't get confused. Let us see the example here. For example, p of x is a polynomial. We are just giving it as a name, which is equal to x square minus 4x plus 3. Now if x equal to 1, I substitute into this polynomial, I get answer 0. Right? Therefore, 1 is the 0 of p of x. Now take another one, x equal to 3. If I substitute x equal to 3, still I get the answer 0. That means 3 is also 0 of the polynomial. Right? Let us see the other one. Suppose I write x equal to 2 and I substitute here p of 2, which is equal to 2 square minus 4 into 2 plus 3, which is equal to 4 here minus 8 plus 3. My answer comes as 7 minus 8, which is equal to minus 1. I don't get 0 here. Correct? It means that x equal to 2 is not the 0 of the polynomial. Correct? Now one more thing you have to observe here. As it is a quadratic polynomial, degree is 2. Correct? That means it will have only two zeros, which already I have shown. One is x equal to 1, another is x equal to 3. So any other value, if you will substitute into this polynomial, you will not get answer as 0. Okay? Let us see the other one now. Nature of the graph. Graph of a linear polynomial ax plus b is always a straight line. So this is the format of the linear polynomial. Right? So whenever the linear polynomial will be there, graph will be straight line. Maybe this way, maybe this way, maybe this way, anyway. Right? Now see, I have written one example here, 2x plus 3. So value of x, if I take 0, so this 2x plus 3, we are going to consider as y, which is equal to this polynomial. So when I substitute value 0, I am getting y is equal to 3. When I substitute minus 2, I am getting y is equal to minus 1. So when I show these points, plot these points on the graph, I am getting a straight line which is passing through these 2 points. If you want to see, just see here, x equal to 0 and y is equal to 3. The point comes at this place. And x equal to minus 2. So y is equal to minus 1. The point comes at this place. And through these 2 points, the line is drawn. It means that for the linear polynomial, the graph is always a straight line. Right? Now, graph of a quadratic polynomial ax square plus bx plus c is an open upward parabola. This shape is called as parabola. Maybe this way, maybe this way, maybe this way, maybe this way. This shape is called as the parabola. Right? Now, the condition is what? If a is greater than 0. A means what? Coefficient of x square. See, here it is shown. A means coefficient of x square. So if it is greater than 0, your graph will always be open upward parabola this way. Okay. Now here I have shown one example. X square minus 3x minus 4. For this one, our a is equal to 1. See, coefficient of x square is 1. Right? It means that definitely our graph will be open upward parabola. Now you see how to draw this graph. X equal to some values we will take and y, which is equal to our polynomial. As I substitute x equal to minus 2, I am getting y is equal to 6. See here, I will show you x equal to minus 2 here. Look, I will just, here you see this value. At this place, you will get minus 6. Oh, sorry, minus 2 and minus 6. Then minus 1 and 0. So minus 1 and 0, this point, 0 and minus 4. 0 and minus 4 this point, 4 and 0, 4 and 0 this point, and 5 and 6 once again at this place. So as we plot these points with a free hand, we just have to draw the curve. So in this way, we are getting the graph of the quadratic polynomial. Correct? Let us see the other one. Open downward parabola. If a is less than 0, that means if the coefficient of x square is less than 0, or you can say it is negative, then the graph of the quadratic polynomial will look as this one. That means open downward parabola. See, so the same example I have taken, only I have changed the signs. Now what happens here? A is minus 1. That means a is less than 0. So definitely the shape of the parabola is this way. Open downward parabola. Look here. Once again, value of x I have taken 2. So I got value of y as minus 6. See here, at this place it will be here. Then minus 1 and 0, this one. Then 0 and 4, 0 and 4. So at this place. Then 4 and 0 at this place. 5 and 6 here. Once again at this place. And with the free hand, we will draw this curve. And we are getting the parabola. Correct? So two things I have told. If the coefficient of x square a is positive, or you can say greater than 0, the parabola will open in the upward direction. And if it is negative, it will open in the downward direction. Correct? Now the another important thing, that is the geometric meaning of the zeros of the polynomial. The zeros of the polynomial p of x are precisely the x coordinate of the points where the graph of y, which is equal to p of x, intersects x-axis. See, how to find out the zeros from the graph. You will just look at the graph, just see the graph where it is intersecting to the x-axis. So that point will be the zero of the given polynomial, right? Now suppose we are having the linear polynomial. So linear polynomial is having only one zero, exactly 1 0. This is the graph of the linear polynomial which I have written here. This one is a polynomial. I'll show you. See here, this is the polynomial here, p of x, which is equal to 2x minus 6. For that, this is the graph. Now this graph is intersecting x-axis at this point. So x, which is equal to 2, is the zero of the given linear polynomial. Correct? So very simple. You don't have to solve, you just have to look at the graph, and wherever that graph is intersecting to the x-axis, this is our x-axis. So that point will be zero of that particular polynomial. Right? Look at the quadratic polynomials. A quadratic polynomial have either two distinct zeros, two equal zeros, that means only one zero but both are same, or no zeros. See, they are saying quadratic polynomial have either two distinct, that means two different zeros. If not, then two equal zeros. If not, then no zeros. So all those three possibilities are there about the quadratic polynomial. Now look at the first graph here. I will show you the first graph. Look at this one here. Here this parabola is intersecting x-axis only at one point. Correct. It means that, but already I said quadratic polynomial, it always has two zeros because degree is 2. Right? But in this case, at only one point it is intersecting. That means that only one zero is there. Correct? So the value of x equal to minus 1. But the another zero is also x equal to minus 1. Both the zeros will be equal. Definitely this has two zeros, but in this case what? Both the zeros are equal. Correct? Now come to the second one here. See here, this one. Now at this place, this graph is intersecting x-axis at two places. That means two distinct zeros. So here also x equal to some value here. At this place also x equal to some value. That means this polynomial has two distinct zeros. Now look at the third one here. This parabola is not intersecting anywhere to the x-axis. Correct. So as it is not intersecting, it means that this polynomial doesn't have the zeros. Correct. Both the zeros are there, but those zeros we cannot show on the number line. Those zeros are, we say, no real zeros. Correct. That means they are imaginary. They are there, but we can just imagine them. We cannot show them here on the graph. So these three possibilities are there about the quadratic polynomials. It means what? The quadratic polynomial at most have two zeros. That means no zeros possible, 1 0 possible, 2 zeros possible. Correct? So these three possibilities are there about the quadratic polynomials. Let us see the cubic polynomial. A cubic polynomial has at most 3 zeros. Maximum how many zeros? 3 zeros. Why? Because the degree is 3. So you will get 3 values of x. But there also, here you see the first one. Only at one place it is intersecting. That means all the 3 zeros are equal. Correct? Now in this case, only at 2 places it is intersecting. That means one of the zero is what? Repeating. If suppose this one is here, so the other one, this value 2 times it will repeat. So in this way, total number of zeros will become 3. Now in this case, all the 3 zeros are present here. So there are here also 3 possibilities. Okay, maybe 1 0 and all those 3 zeros will be equal. Now 2 zeros, but out of those 2 zeros, one value will repeat. Now 3 zeros. For the cubic polynomial, no zeros will not be there. Okay, 1, 2 and 3 zeros are there. You don't have to mug up all those things. Just what? Look at the graph, at which point it is intersecting, write down that value of x, and that one will be the zero of the given polynomial, and that's all. Nothing else. Correct? Now here. Look at exercise 2.1. Question number 1. The graph of y is equal to p of x. Try to understand the meaning of this one. Here, y which is equal to p of x, it means that your polynomial is in x variable. Always it's supposed to be like this. Sometime they may write down x which is equal to p of y. If this is the condition, that means your polynomial is in y variable. So whenever the polynomial will be in the y variable, you will look at the y-axis where the graph is intersecting to y-axis. Okay, but most of the time what they give you, the polynomial y which is equal to p of x, that means your polynomial is in x variable, right? Then you will look at the x-axis. Now look at this one, first one here. This graph, this line is not intersecting to the x-axis. That means for the first question, no zeros. Here what will write down? No zeros. Now look at the second one. Only at one place it is intersecting. So what we'll say? It has 1 0. Now for this one, 1, 2 and 3. At 3 places. That means how many zeros? 3 zeros. Here 1 and 2. Here 2 zeros. 1, 2, 3, 4. So 4 zeros. 1, 2, 3. So 3 zeros. Just look at the graph. How many times it is intersecting to the x-axis? Count, write down the number of zeros, and that's all. Correct? I hope all of you understood this one. Thank you.